I want to commend Greg Weiler for his presentation. This is one of the more exciting developments, in my opinion, in the last several years, the real opportunity to provide significant connectivity for a community around the world which has been largely disenfranchised. I'm going to try to go quickly through my material, and David, I'll rely on you to interrupt. Really, let me say, please interrupt. I'm an old Stanford professor, and the problem is I've got this trapped audience, and I could go on forever. So I really want to respect the intent to get some Q&A time as well. This is one way of looking at the internet. It was an automatically generated image by Bill Cheswick looking at the connectivity of the network. So each color is a different autonomous system, and you get the impression that the internet in 1999, and frankly 10 years later, it still looks like this, maybe a lot bigger and a lot more colorful, but still the impression is a great deal of connectivity around the world. And indeed, this would not work were it not for the fact that literally hundreds of thousands of different operators are cooperating with each other. This is not a system provided by a single provider. This is not a top-down structure. This is a structure which requires cooperation among a great many different suppliers. And in some very real sense, each person in the room with a personal network at home, a Wi-Fi net, for example, is owning and running a small piece of this gigantic system. So collaboration and cooperation are really fundamental to the internet. It was designed with that in mind. The intent was if you could build a piece of the internet and follow the specific protocols, that you could be part of the system. And indeed, over the last 30 years since this design was originally put together, we've seen a remarkable outpouring of interest in it. If we look a little bit at the statistics of the net, the only data I have right now is from mid-2008. There were almost 600 million identifiable machines on the network, not counting things that are episodically connected. So these are the servers, the web servers, the email servers, the other kinds of application video servers, and so on, that have domain names and have, generally speaking, dedicated IP addresses, and about 1.5 billion users. Now, in this same decade, from the 1990s to the present, almost 3.5 billion mobiles have entered into the system. And this is actually a remarkable change to the Internet's environment, because some 15% or so of those mobiles are Internet enabled. The consequence of that is that for any company, Google included, trying to offer Internet-based services to people around the world, for a great many of them, the first introduction they will have to Internet service will be through their mobiles and not through a laptop. So figuring out how to offer services through a relatively constrained display space and sometimes awkward keyboard is quite a big challenge, but it's absolutely vital to make sure that all the services of the Internet can somehow be delivered through that means. The people on the net have changed over the last decade as well. I'm thinking about Greg's other 3 billion and then thinking about where the world's population is. And as you can see, the single largest grouping of Internet users today is in Asia, defined roughly speaking as China and India, Indonesia, Malaysia, Japan, and so on. Almost 600 million people, but only 15% of the population in that region currently penetrated. So imagine the scale of penetration when Asia becomes 73% penetrated, as we are in North America. Of course, the numbers now are in the billions. What's important about that is that the interests, the culture, the languages and style of the Asian populations will color the Internet's use and its appearance. So it's important for everyone who currently experiences the Internet to recognize that as this rapid growth in Asia continues, and as O3B contributes to that, that there will be significant visible changes in the way the Internet looks and behaves simply because of the way the users use it. Europe is the second largest grouping. I mean, 10 years ago, it would have been North America that was largest. It has almost 400 million users as of the middle of last year. Of course, I've given up making any predictions at all about Europe because they keep adding countries. So, you know, defining Europe has become somewhat problematic. There are more Chinese online now than there are citizens in North America, in China, or in Canada and the U.S., just to give you an example. But as you can see, in Africa, for example, the penetration is quite low. Even though there's internet access in most capital cities of Africa, it doesn't spread very much beyond that. Mobiles are helping in some ways, but again, I hope that the initiatives like Greg's at O3B will make a big difference. Well, let's try to look at the landscape of internet and try to understand what's happening. Moore's law has failed. If you haven't noticed that, it's fairly important. We no longer get chips whose clock speeds are doubling every 18 months. Instead, what we're getting is chips with more cores on them, more processors on each chip. That means that the total number of cycles available on the chip are increasing, but it's not as a consequence of increased clock speed. It's because of the increased number of processors. Now, you might say, well, who cares? Well, we're getting the same number of cycles increased every 18 months, so what's the problem? Well, problem number one is that many of the algorithms that run are serial in nature, and they can't take advantage of all the parallel cores unless they can be parallelized. So that's problem number one. Problem number two is that trying to keep all of those processors busy means moving data back and forth on and off the chip. And sometimes the ability to move data from memory onto the chip for processing and back is limited and maybe not even adequate to keep all of those cores functioning. So there's some real issues here, trying to take advantage of this new form of Moore's law, if you like. The reason that we're not seeing the clock speeds continuing to go up as they did before is that in order to do that, you need to drive more power into the chip. That causes more heat radiation. That causes the chip to potentially, if not melt, at least not function at such high temperatures. We're also seeing that conventional database technology is not scaling to the petabyte sizes that many of us, including Google, are experiencing, or even exabyte. And so we're having to look to new kinds of designs for handling extremely large data contents. There's also a very visible need to segregate and aggregate information. What we see this coming about from virtual private networking, from corporate enterprises that are trying to isolate their systems from the rest of the unwashed internet. But then we're also seeing cloud computing happening, which I'll come back to in a bit, where a lot of information from different parties are being aggregated, and we have to find some way of keeping people from either accidentally or deliberately getting into each other's information. We're also seeing just huge volumes of digital information being accumulated. Sensor networks are starting to become more common on the internet. There's all this digital scanning of things. There's digital production of audio and video. The World Wide Web and blogging and all the websites and everything else are all there's a bug in this. There you go. Okay. It's a bug in your processor, Greg. I hope that isn't a big issue here. You can take it up with IBM. So all this digital content is flowing into the net, and we have to do something with it. And then there's this really awkward problem. The simple way to put this is it's the year 3000. You've just done a Google search, and you've discovered a 1997 PowerPoint file. Now let's even imagine you're running Windows 3000. The question is, does it know how to interpret a 1,000-year-old PowerPoint file? And the answer is, I don't know, probably not. And that's not a gratuitous dig at Microsoft at all. Even if this were open source software, it's a little hard to imagine a piece of software lasting 1,000 years. So the problem of bit rot is quite real. We are generating very complex digital objects using very complex pieces of software. And over time, even if we preserve the bits of those objects, if we don't have access to the software that can interpret the bits, they're just a pile of rotten bits. And I'm actually very, very worried